Hello everyone, I welcome you all in this video. So in this video I will be talking about my future research plan, and I hope you have seen the last video where I have talked about my research journey, past research and current research as well, and little bit of a future. But in this video we will discuss in detail. So in a future I will continue to work on my aircraft design problem and my spin recovery problem, flight controller design problem, reconfigurable flight simulator design problem, hardware in loop simulation problem, and more we'll discuss. So as far as the aircraft design part is concerned, although the full UAV design is not considered to be research, but part of the research can be implemented to make it good on a product level. So here different UAV design depending upon the mission requirement will be working in the future. Design replication, that means if you have seen some uh, design and you are very much inspired, then how actually you can replicate the design. And part of your controller research, how can you implement in the UAV to make it complete or partially indigenous, and to meet the specific mission requirement. That means if there is any sort of mission requirement is given, round only you have to design the UAV and make it more indigenous, more intelligent. So that work will be continue from the flight dynamics and control perspective. Okay, because my research area is flight mechanics and control. Now moving towards my primary research problem, spin recovery. So I will be looking to make a dedicated setup on a spin tunnel. So I have already started doing some small work with the available resources, where you can see here small paper is floating in a small scale spin tunnel. So when I will get a fund opportunity resources, I will scale up, and uh, I will relate the UAV design part with my simulator work also. For example, let's say if any UAV has been designed or aircraft designed, you have to have a little some kind of a verification. So we can design our fixed based own simulator where you can actually deploy our aircraft dynamics, control law, actuators model, everything in some kind of software like MATLAB and Simulink, and you can send those trajectory data to some kind of software like flight gear explain to have a some kind of verification of a design. I means how my aircraft is behaving. Okay, for example, you can send the control stick command to the MATLAB or any other software. The computation will be keep going on in the master computer, and then the data you can send. So actually in this, if you are adding some kind of any control logic, any if you are making any, if you are including any kind of hardware model, you can model in the Simulink, or any additional control surface you want to integrate apart from the flight control surface, how it will behave on a simulation level, you can actually see this. And that is reconfigurable. Basically when you have a different kind of aircraft, you just need to change the aircraft aerodynamic model design parameter, and simulator will be ready to fly for a different kind of UAV. Okay, more extensive work can be done in this area. Okay, regarding the autopilot design is concerned, flight controller design is concerned, so we will be happy to work, we are working actually, and will be happy to work, we will continue to work in this area where you can design your flight controller from the scratch, all the control loops, and then you can deploy this controller to the any other existing hardware or on own hardware to test the flight controller performance. Okay, so here there is a many different way to design the flight controller, and many different control approach can be followed. For example, PID, INDI, all are respected controller, because but everyone has a certain advantage and disadvantage. So what we can do here, we can actually adopt some model based controller like PID, INDI, where these are controller are very good when there is a external disturbance are known and aerodynamic models are known, but if there is a certain kind of unmodeled dynamics is there, so how will you compensate this? So we can actually adopt the hybrid type of controller. For example, apart from INDI or PID, we can use artificial intelligence neural network based controller to estimate the online disturbance in a real time, and you can counter those disturbance. So by respecting the standard controller, you can even use this controller in a upset flight scenario where you can actually model the disturbance online and you can compensate. So this work will be continue, and regarding the hardware in loop simulation, I will be happy to continue, and I will be, if I will get the opportunity, I will scale up. So here you can see that we have developed a small model, hardware in loop simulation model, where you can actually test the motor parameters, thrust, torque. You can actually have a battery health. You can actually replicate the aerodynamic loading, and this can be used for both VTOL, fixed wing on hybrid aircraft. So we will, when we will have a opportunity, we will scale up this work, because it is important to test to every component in the ground itself before fitting into the flight. And also, if any kind of ground test if you perform, then you can get those results and make your simulation high fidelity. For example, actuator characterizations, sensor delay, etc. And apart from aircraft, I will be happy to work on the other aerospace systems like satellite and rocket, regarding the flight controller. So if anything's new come to me, I will happy to share, and any new research domain if I will add in my research journey, then sure I will update you, and I am always ready to collaborate. If anyone is interested, please contact me. Thank you so much.